All right, so in this example, we're seeking to write an equation that meets certain requirements. And so our first one, we want it to be the shape of x squared, but shifted right 6 units and up 2. So what do we know that's going to make us shift right 6 units? We know it's got to be an inside change. And we remember that it's x minus a number. So in this case, x minus 6. So that's going to cause this is going to make us go right 6. But then we also need to go up 2. So remember, that part is an outside change. So we're just going to add 2 onto our output. So this is our up 2. So don't make these harder than they are. It does get a little tricky with some of the reflections and things like that. And actually, I might make this one maybe a little more complicated. Let's see. Oh, no, we'll be fine. All right, so the shape of y equals 1 over x, but reflected across the x-axis and shifted up by 1 unit. So reflecting over the x-axis, remember that's this kind of shift, right, to make the y outputs negative. So we've got negative f of x is going to be where our negative needs to go there. So we're going to have y equals negative 1 over x. But then we also need to shift it up 1, right? So we're going to have a plus 1. So this is our up 1, and this is our reflect over the x-axis. Okay, so some of these, the nice thing about these guys is that you can write what you think is the equation, put it into GeoGebra, and see if you accomplished what you wanted to. So what will happen, let's see, we'll go ahead and throw 2 into this one. So what will happen if we start with the function square root of x, and I tell you, okay, I've got a new function, it is negative square root of x. And so we have that negative there, we know it's a reflection, and we know that it's outside change, so that's going to make all my y's the opposite sign, so we are reflecting over the x-axis. All right, so this is really f of x equals the square root of something, right? So what about our next function? Here, this time we've got the negative under the radical. So this is an inside change because it's inside the box here, inside change. So still a negative, so we know it's a reflection. But this time it's not over the x-axis, it's going to be over the y-axis. So basically we're putting our the opposite signed x value is going to give you the same y value. So our normal function would look roughly like that, and reflected square root of negative x is going to do this. Square root of negative x, right? Versus negative square root of x, which would be looking like this. So negative, so we'll say y equals negative square root of x. And then of course we'll have y equals square root of x. Okay, what else do we have? We've got c of x equals 3 times the square root of x. This is going to be a vertical stretch by a factor of 3. So this is going to kind of make it look narrower. For this one, because I can't sketch real well, we're going to pull up GeoGebra and look at it. All right, so here we've got our function y equals square root of x, and we're going to do our other function. Our next one, it was 3 times the square root of x. And so you can see each one of our outputs is 3 times greater than what it was. So my point, like 1,3 on the graph, sorry, not 1,3, 1,1 on the first graph is now become 1,3, right? So each one of those is 3 times higher than it was. So this kind of has the effect of making it look kind of narrower than what it was. All right, so this is making it look narrower. Now, what about if we do it 1/5 x? We're doing a vertical shrink or a vertical compression. And we can say by a factor of 5. And this is really going to have the effect of making it look wider. So let's look at that on GeoGebra. So here I'm going to turn off the 3 times the cube root, or 3 times square root. We're going to do y equals 1/5 times the square root of x. And that's our red plot here. And you can see that it looks like we squished it. It looks like we made it flat as a pancake, kind of, right? So that 0.1 comma, the 0.1 comma 1 is now 1 comma 1/5. So everything's lower on our graph. Okay. So what do we got next? Square root of x minus 3. Of course, that one's easier, right? That one's going to be a vertical shift. Sorry, horizontal shift. Said the wrong word. Horizontal shift. Now, which way are we going? We're going to be going to the right. Because if I plug in x equals 3, it's going to make it the square root of 0. So we are going right 3 units. So if we were to sketch that on our little graph, what have we not used? Blue. Every point on the graph would be going over 3. So we'd be looking something like that. Now you compare that with square root of x minus 2, right? This is now an outside change, so this is going to be a vertical shift. A vertical shift down 2 units. And so we would take our red graph and move it down. I think I'm out of colors. We'll make it orange. It's going to look a little weird, kind of like that. So here's our square root of x minus 2. Now we've got one more. We're going to throw a whole bunch of changes in here. We've got a horizontal shift. This one's going to be only left 1 unit. We've got a reflection over the x-axis. Reflect over x-axis. We've got a vertical stretch by a factor of 2. And we've got a shift up 3 units. It's all pretty complicated there. So let's look at that one real quick. In GeoGebra, we can because I think it's going to be easier to track there. We'll turn these off. All right, so we've got our square root of x. We're going to do our changes one at a time. So we've got square root of x. We had plus 1. There we've gone and shifted left 1. And what about if we do negative square root of x plus 1? That's going to just reflect it over the x-axis. And if I do negative 2 square root of x plus 1, that's going to make it kind of stretch it vertically. And then we're going to shift the whole thing up 3, right? Y equals negative 2 times square root x plus 1. And then outside the radical plus 3 just went right on up 3. So that's a fairly complicated example. I think we've got one left, and we'll save it for the next video.